Picture this: over 600,000 water buffaloes living across farms in the United States, each one producing milk so rich that it takes just 4 gallons to make what would require 6 gallons from a regular dairy cow. These magnificent animals are the secret behind authentic mozzarella cheese, the kind that stretches perfectly on pizza and melts into creamy perfection in lasagna. But how do modern farms manage thousands of these powerful creatures? What makes buffalo milk so special for cheese making? And how has American agriculture transformed an ancient tradition into a cutting-edge industry? Welcome to AgriCraft, where we explore the real stories behind your food. All will be revealed in this video. Water buffaloes have been domesticated for over 5,000 years, originating in the river valleys of Asia, where they earned their name by spending hours submerged in water to stay cool. While most people associate these animals with rice paddies in Southeast Asia, they have become increasingly important in modern farming operations worldwide. The story of buffalo dairy farming in America began in the late 20th century, when innovative farmers recognized that buffalo milk contained almost twice the fat and protein of cow milk, making it ideal for premium cheese production. Today, the United States produces over 40 million pounds of buffalo mozzarella annually, with farms scattered across states like California, Texas, Florida, and North Carolina. Italy remains the global leader, producing more than 33,000 tons per year, but American operations are rapidly expanding as consumer demand for authentic mozzarella continues to grow. What makes this industry truly remarkable is how agriculture technology has adapted traditional practices to create efficient, sustainable systems that can raise thousands of animals while maintaining the highest standards of animal welfare and milk quality. The journey begins with careful breed selection. While there are 2 main types of water buffalo, river buffalo and swamp buffalo, dairy operations exclusively use river buffalo breeds, such as Murrah, Jafarabadi, and Mediterranean. Murrah buffalo from India are considered the gold standard, with mature females weighing between 1,200 and 1,800 pounds and producing up to 3,000 gallons of milk per lactation period. American farmers either import breeding stock or work with domestic breeding programs that have established pure bloodlines over multiple generations. A single high-quality breeding buffalo can cost between $5,000 and $15,000, representing a significant investment that pays dividends through superior genetics passed to future generations. The breeding process itself requires expertise and careful timing. Female buffalo reach sexual maturity around 15 to 18 months, though most farmers wait until they are at least 2 years old before first breeding. The gestation period lasts approximately 310 days, slightly longer than cattle. Modern farms use both natural breeding with proven bulls and artificial insemination with frozen semen from champion bloodlines, allowing genetic improvement across the entire herd. Newborn buffalo calves enter the world weighing between 60 and 90 pounds, considerably larger than dairy calf counterparts. The first hours are critical as calves must receive colostrum, the antibody-rich first milk that provides essential immune protection. Unlike some industrial dairy operations that immediately separate calves, many buffalo farms allow calves to nurse directly for the first few days, recognizing that buffalo cows are extremely protective mothers and separation causes significant stress. After this bonding period, calves are gradually transitioned to dedicated calf housing, where they receive milk replacer or whole buffalo milk for the first 8 to 12 weeks. The calf facilities maintain strict hygiene standards with daily cleaning and temperature control to prevent disease. Each calf receives identification through ear tags and increasingly through microchip implants that allow tracking of health records, breeding history, and milk production throughout their entire life. Environmental requirements for buffalo farming differ significantly from conventional dairy cattle. Water buffalo are remarkably adaptable but thrive in warm, humid climates and absolutely require access to water for bathing and cooling. Farms must provide either natural ponds, artificial wallows, or sprinkler systems. Because buffalo have relatively few sweat glands and rely on water immersion or mud baths to regulate body temperature. In hot weather, buffalo that cannot cool themselves properly will eat less, produce less milk, and face serious health risks. A typical buffalo will spend 2 to 4 hours daily in water during summer months. Modern sustainable farming operations design pastures with integrated water features that serve multiple purposes: cooling for animals, natural fertilization of aquatic vegetation that buffalo graze, and habitat for beneficial insects and wildlife. The pastures themselves combine permanent grasses with legumes that fix nitrogen naturally, reducing fertilizer requirements. Buffalo are efficient grazers that can thrive on roughage that would be inadequate for high-producing dairy cows, making them excellent choices for marginal land unsuitable for crop cultivation. Nutrition management is where agriculture technology truly shines. While buffalo can survive on grazing alone, lactating females producing commercial quantities of milk require carefully balanced diets. Nutritionists formulate rations combining pasture grass with hay, silage, grain concentrates, and mineral supplements. A producing buffalo typically consumes between 30 and 40 pounds of dry matter daily, less than a comparable dairy cow but with higher nutrient density requirements. Many farms have installed automated feeding systems where conveyor belts deliver precisely measured rations to feeding stations multiple times daily. These systems reduce labor costs while ensuring consistent nutrition. The feeding areas include computerized scales that weigh each animal and adjust individual portions based on production levels, body condition, and lactation stage. Buffalo are creatures of routine and quickly learn to enter feeding stations where radio frequency identification readers recognize their microchip and dispense their customized meal. As buffalo mature, the differences between this species and cattle become increasingly apparent. Adult buffalo are remarkably intelligent, with excellent memories for locations, routines, and individual humans. They are also much stronger than cattle, with mature bulls weighing up to 2,500 pounds of solid muscle. This power means facilities must be built considerably stronger than conventional dairy barns. Fencing uses heavy-gauge steel panels rather than wire, and handling facilities employ solid walls and hydraulic gates. However, buffalo that are raised with consistent, gentle handling from birth are generally calm and cooperative. Problems arise when animals are frightened or handled roughly, as their flight response is powerful and their memory for negative experiences is long-lasting. Breeding females enter their first lactation after giving birth around 3 years of age. The transformation from pregnant heifer to producing dairy animal is carefully managed. In the weeks before calving, expectant mothers are moved to maternity areas with extra bedding and close monitoring. Most buffalo give birth without assistance, but farm staff check these animals multiple times daily to ensure any problems are caught early. After calving, the new mother and baby spend several days together before the calf is weaned to group housing. The mother then enters the milking herd, where she will be milked twice daily for approximately 300 days before being dried off to rest and prepare for her next calf. The milking process combines traditional knowledge with modern industrial machines. Buffalo typically produce between 8 and 14 gallons of milk daily during peak lactation, roughly half the volume of elite Holstein cows, but with dramatically different composition. Buffalo milk contains 8 to 9% fat compared to 4% in cow milk, and 5% protein versus 3%. This means every gallon of buffalo milk yields substantially more cheese. It also means the milk is thicker, richer, and requires different handling. Modern milking parlors designed for buffalo use parallel or rotary systems where groups of animals enter, are milked simultaneously, and exit together. The parlors include automated systems that clean teats, attach milking units, monitor milk flow, and detach units when each animal finishes. Computers track production from each buffalo, alerting staff to any animal producing significantly more or less than expected, as this often indicates health issues requiring attention. Quality control begins the instant milk leaves the buffalo. The milk flows through stainless steel pipes to refrigerated bulk tanks, where it is immediately cooled to below 40 degrees Fahrenheit to prevent bacterial growth. Samples from every milking are sent to laboratories for testing of fat content, protein levels, somatic cell counts that indicate udder health, and presence of antibiotics or contaminants. Any milk that fails testing is discarded and never enters the food supply. The stringest food safety standards apply because buffalo milk is often consumed as artisanal cheese with minimal processing. Temperature control is critical throughout, as the high fat content makes buffalo milk spoil more quickly than cow milk if improperly handled. Modern bulk tanks use automated systems that continuously circulate and cool the milk while recording temperatures digitally, providing documentation for food safety inspections. Transportation to the processing plant happens daily or every other day, depending on farm size and distance to the cheese facility. Insulated tanker trucks maintain cold chain integrity, with milk never allowed to warm above 45 degrees. Upon arrival at the processing plant, every load undergoes additional testing before being accepted. Technicians check temperature, run rapid tests for antibiotics, and assess general quality. Rejected loads are refused and the farm must dispose of that milk, representing significant financial loss and incentive to maintain excellent hygiene standards. Accepted milk is pumped into massive refrigerated silos capable of holding thousands of gallons, where it awaits transformation into mozzarella. The processing plant itself is a marvel of industrial processing technology combined with artisan cheese-making traditions. Workers wear full protective equipment, including hair nets, beard nets, gloves, and sanitized boots. The facility operates under strict temperature and humidity controls with positive air pressure systems that prevent outside contaminants from entering. Every surface is stainless steel or food-grade plastic, designed for easy cleaning and sterilization. The cheese making begins by transferring milk into large vats holding from 500 to 2,000 gallons. The milk is gently warmed to around 95 degrees while cultures of specific bacteria strains are added. These cultures begin acidifying the milk, developing the flavor profile and preparing it for the next step. After 30 to 45 minutes, rennet is added. This enzyme, traditionally sourced from calf stomachs but now often produced through fermentation, causes milk proteins to coagulate and separate from the liquid whey. Within 15 to 30 minutes, the milk transforms into a solid curd floating in yellowish whey. Automated cutting tools with wire harps slice through the curd mass, creating small cubes that release more whey. The curd and whey mixture is gently stirred while being slowly heated to about 108 degrees over the course of an hour. This cooking process firms the curd, giving it the proper texture for mozzarella. Temperature control during this phase is critical, as cooking too quickly creates tough, rubbery cheese while insufficient cooking yields soft, mushy results. Sensors throughout the vats constantly monitor temperature, and computerized systems adjust heating elements to maintain perfect conditions. When the curds reach the correct firmness, the whey is drained away through screens. This liquid is not waste, but rather a valuable byproduct. Whey contains lactose, minerals, and some proteins, making it useful for animal feed, fertilizer, or further processing into whey protein powder sold to the supplement industry. Some plants have installed membrane filtration systems that separate whey components into various products, ensuring almost nothing is wasted. The drained curds are allowed to mat together on the bottom of the vats, forming a thick layer. The acidity continues to develop through bacterial action. Cheesemakers test the curd repeatedly using pH meters and stretch tests where a small sample is mixed with hot water to see if it achieves the desired elastic texture. When testing confirms readiness, typically after 2 to 4 hours of acidification, the mozzarella making enters its most distinctive phase. The matted curd is cut into large chunks and fed into industrial machines that are essentially giant mixing bowls filled with hot water between 150 and 170 degrees. Rotating paddles knead and stretch the curd in the hot water, causing the protein structure to align and creating mozzarella's characteristic stringy texture. This is where chemistry becomes edible magic. The heat and mechanical action cause the calcium-bonded protein network to soften and become pliable while maintaining enough structure to hold together. As the curd is worked, It transforms from crumbly chunks into smooth, glossy, elastic mass that can be stretched several feet without breaking. For traditional mozzarella balls, workers or automated systems pull portions of the stretched curd and form them into spheres through a combination of stretching, folding, and pinching. The formed balls are immediately dropped into cold water or brine to cool and set their shape. Large operations use automated forming machines with heated molds that shape consistent portions, depositing finished balls onto conveyor belts that carry them through cooling tanks. A single processing line can produce several thousand mozzarella balls per hour. For low-moisture mozzarella used on pizza, the process differs slightly. The stretched curd is pressed into blocks, cooled, and then passed through industrial slicers or shredders before packaging. This style has lower water content and better melting characteristics for commercial pizza operations. Quality inspection happens continuously throughout the processing plant. Samples from every batch undergo texture analysis, moisture content testing, fat content verification, and microbiological screening. Trained assessors evaluate appearance, taste, and stretchability. Any batch failing standards is either reprocessed or discarded. Cheese that passes inspection moves to the packaging area, another zone with strict hygiene standards and temperature control. Fresh mozzarella balls are packaged in sealed plastic containers filled with liquid, either water, brine, or whey, which preserves moisture and prevents spoilage. Automated systems fill containers, seal lids, apply labels with production dates and nutritional information, and pack units into cases. Low-moisture mozzarella is vacuum-sealed in plastic film that removes oxygen and prevents mold growth. The packaged cheese immediately enters cold storage facilities maintained at 36 to 38 degrees. The relatively short shelf life of fresh buffalo mozzarella, typically 3 to 4 weeks, means efficient distribution is critical. Products are loaded onto refrigerated trucks and shipped to distributors, retailers, restaurants, and pizzerias across the country and internationally. Some premium buffalo mozzarella is air freighted to maintain freshness, with Italian and American producers shipping products worldwide to meet demand from high-end restaurants. The logistics of moving perishable dairy products involves sophisticated supply chain management, with every package tracked digitally from processing plant to final destination. Back at the farm, the herd management continues year-round. Buffalo that are not currently producing milk because they are between lactations still require daily care. Dry cows receive different rations focused on body condition, maintenance, and fetal development for those that are pregnant. Young heifers not yet bred are raised in separate groups with specialized growth diets. Bulls used for natural breeding are housed individually or in small bachelor groups, as mature males can be aggressive toward each other. These breeding bulls represent the genetic future of the herd and receive exceptional care, including hoof trimming, health monitoring, and semen collection for those used in artificial insemination programs. Health management in buffalo herds requires veterinarians experienced with the species. While buffalo are generally hardier and more disease-resistant than dairy cattle, they still face health challenges. Mastitis, infection of the udder, is monitored through somatic cell count testing in milk samples. Hoof problems are addressed through regular trimming and use of foot baths containing disinfectants. Parasites are controlled through strategic deworming based on fecal testing rather than routine medication, reducing antibiotic use and supporting sustainable farming practices. Vaccinations protect against common diseases, with protocols adapted from cattle medicine but adjusted for buffalo physiology. Modern farms maintain detailed health records electronically, allowing quick identification of animals needing treatment and tracking of all medications to ensure proper withdrawal periods before milk from treated animals enters the food chain. Environmental sustainability is increasingly central to buffalo dairy operations. These animals produce methane through their digestive process, but several factors make buffalo more environmentally friendly than typically assumed. First, their efficient feed conversion means less feed input per unit of protein and fat produced compared to cattle. Second, their ability to thrive on pasture reduces dependence on grain crops that require intensive cultivation. Third, Their manure is valuable fertilizer that farms collect and either compost or use in anaerobic digesters that generate biogas for electricity and heat. Some innovative operations have installed digesters that process manure from thousands of buffalo, producing enough renewable energy to power the entire farm with surplus sold back to the electrical grid. The liquid effluent from digesters becomes nutrient-rich fertilizer with reduced odor and pathogen load compared to raw manure. This closed-loop system where waste becomes resource exemplifies modern sustainable farming. Water management is another crucial sustainability consideration. While buffalo require substantial water for drinking and bathing, farms can design systems that recycle and reuse water. Bathing ponds are often natural or constructed wetlands that filter water through plant roots and beneficial microorganisms. These wetlands support biodiversity, providing habitat for birds, amphibians, and beneficial insects. The nutrient-rich water supports rapid plant growth that is then harvested as supplemental animal feed, creating another closed loop. Some farms have implemented rainwater harvesting systems that capture precipitation from barn roofs into storage tanks, reducing dependence on well water or municipal supplies. The economics of buffalo dairy farming require significant capital investment, but offer attractive returns for well-managed operations. A basic setup for 100 milking buffalo, including land, facilities, animals, and equipment, requires investment approaching $1 million or more. However, buffalo milk commands premium prices, typically 2 to 3 times the price of cow milk, and the cheese made from it sells at even higher multiples. A single buffalo producing 3,000 gallons during a lactation can generate gross revenue of $12,000 to $15,000 annually, just from milk sales, not including value from calves or meat from culled animals. The higher butterfat content means cheese yields are exceptional, with 100 pounds of buffalo milk producing approximately 24 pounds of mozzarella compared to 9 to 10 pounds from the same weight of cow milk. This efficiency allows smaller operations to be economically viable, supporting farm diversity and rural economic development. The meat from buffalo is another revenue stream. While not the primary product, male calves not needed for breeding and females culled from the dairy herd are processed for meat. Buffalo meat is leaner than beef with a distinctive flavor prized in certain markets. The dark red meat has less than half the fat of comparable beef cuts, while providing similar protein levels. Specialized processors buy buffalo specifically for meat programs, paying prices competitive with quality beef cattle. This ensures that dairy operations can profit from every animal rather than viewing male calves as waste. A significant improvement over conventional dairy systems, where male calves have limited value. Culinary applications of buffalo mozzarella extend far beyond pizza, though that remains the most common use in America. Fresh buffalo mozzarella features prominently in Italian cuisine, especially in Campania, where the protected designation of origin mozzarella di bufala campana is produced. The cheese appears in caprese salad with tomatoes, basil, and olive oil, showcasing its delicate, slightly tangy flavor and creamy texture. It melts into risottos, enriches pasta dishes, and provides luxurious filling for stuffed vegetables. High-end restaurants feature buffalo mozzarella prominently, often noting its origin on menus as a mark of quality. The rise of artisan pizza in America has driven increased demand for authentic buffalo mozzarella, as chefs recognize the superior melting characteristics and complex flavor it brings to Neapolitan-style pies. Nutritional value of buffalo milk and cheese is impressive. The higher protein content includes greater proportions of essential amino acids necessary for human health. The fat in buffalo milk contains more beneficial fatty acids, including conjugated linoleic acid, which research suggests may have health-promoting properties. Buffalo milk is naturally whiter than cow milk because it contains minimal carotene, the yellow pigment found in cow milk fat. The cheese is rich in calcium, phosphorus, and vitamins A and B12. Some people who experience digestive issues with cow dairy find buffalo milk easier to tolerate, though it still contains lactose and is not suitable for those with true lactose intolerance. The nutritional density means smaller portions provide substantial nutrients, making buffalo mozzarella a nutrient-dense food choice despite its high calorie content from fat. Looking at the complete cycle from breeding through milking to cheese production and distribution reveals the complexity of modern food systems. What appears in the grocery store as a simple ball of white cheese represents years of selective breeding, months of pregnancy and lactation, hours of skilled cheesemaking, and sophisticated logistics. Each step requires expertise, investment, and commitment to quality. The transformation of an ancient domesticated animal into a pillar of cutting-edge American agriculture demonstrates how farming evolves to meet changing consumer preferences while maintaining connections to tradition and artisan quality. The future of buffalo dairy farming in America looks promising. Consumer interest in sustainable farming, artisan foods, and authentic ingredients continues growing. Buffalo naturally align with these trends through their efficiency, adaptability to pasture-based systems, and production of premium products. Agriculture technology will continue improving management through precision monitoring systems, genetic selection tools, and automated equipment that reduces labor while enhancing animal welfare. Research into buffalo nutrition, reproduction, and health will yield practices specifically optimized for this species rather than adapted from cattle research. As climate patterns shift, the heat tolerance and water efficiency of buffalo may make them increasingly attractive for dairy production in regions where cattle struggle. From the pastures where thousands of buffalo graze and wallow to the processing plants where their milk becomes culinary gold, this industry exemplifies modern agriculture at its finest. It balances animal welfare with economic viability, traditional practices with industrial efficiency, and local production with global distribution. Every slice of buffalo mozzarella on your pizza, every creamy ball in your caprese salad, represents the dedication of farmers who wake before dawn to care for their herds, the skill of cheesemakers who transform milk into art, and the power of agriculture technology to make ancient traditions viable in contemporary markets. Thank you for watching this exploration of sustainable dairy farming and buffalo mozzarella production here on AgriCraft. If you found this journey from farm to table informative, please hit the like button and subscribe to our channel for more deep dives into how American agriculture feeds the nation and the world. Leave a comment below telling us about your favorite way to enjoy buffalo mozzarella or questions about anything we covered today. Until next time, keep exploring the remarkable stories behind your food.